Today is the 5th of December 2023, and would like to continue looking at some more possible questions, and that will be our 12th video. Thank you to everyone who have subscribed to our videos. Okay, and if you have not done it already, can you consider, please consider subscribing, sharing, liking, and following us. Okay, I'll really appreciate that. And if the account is not yours, please ask permission from the account holder, or you can open your account. You can ask somebody to help you open your account. Okay, I'll really appreciate that. Okay, if you can subscribe to our channel. I normally write, please follow my note/script. Okay, you won't understand what I mean if you are just listening. At times it's good to just follow the notes, because assuming I'm saying y is directly proportional to x, okay, and you hear otherwise, please go by the notes, okay, that I've made. Beware of scammers, please. Beware of them. Okay, beware of them. Don't be scammed. Watch last video for recap, because we are doing possible questions. It's not in any order, but what I'll do is there are some topics I haven't done. Okay, so after doing some sets of questions, I'll go back and do those topics, and then we'll do some more questions, so that the people who are doing their exam next year can be fully prepared for that. Our starter for today. Yesterday we saw this proportionality sign. I haven't done it, but I thought I'll use the starter just to explain, in case we meet another question before we do the video. And I just wanted to say, maths is the same kind of questions that they keep on repeating. They can twist it a little bit, but the chances are you've done the topic. So even if you've not done that type of question, it's just a little twist, and just starting from what you know to the unknown. So far, that's what we've been doing, and you realize that it works a lot. Okay, so when you get the information, start with what they've given you and start working towards it, and ask yourself, what do I know, or what have I learned that can help me solve this question the easiest possible, and being accurate as possible. Okay, that is the proportionality sign. Okay, the proportional sign. Okay, if you say directly proportional, it's either both variables are increasing or decreasing. So if y is proportional to x, then y will be increasing at the same time, whilst x is also increasing. If y is decreasing, x is also decreasing. Okay, inverse proportion means maybe y is increasing and x is decreasing, or y is decreasing and x is increasing. Okay, now if y is directly proportional to x, then this is how it will look. Y is directly proportional to s. So immediately you bring the equal to sign, you introduce a constant. Okay, so y equals kx. Okay, so like what we saw yesterday, they gave us one of the values and we solve for the constant, and then we solve for x, but we got two values of x, and they said to us y is greater than 0, so we chose the positive of the x. Okay, that was what we did yesterday. I encourage you again, go back and watch the video. If y is directly proportional to x squared, it will be, this is how it will look like. Y is directly proportional to x squared. So it means when y is increasing, x squared is increasing. When y is decreasing, s squared is increasing. If you introduce the equal to sign and your constant, you have y equals kx squared. So if they give you a question in that, then this is the equation you are going to use to find your constant. And then whatever values you have, you use them to find one variable, put it back into the equation and find the second variable like we did yesterday. Y is directly proportional to x minus 1. So it's not always x and x squared. It can be x minus 1, 2x minus 1, 2x, whatever they give you, that is what you are going to use for the equation. So y is directly proportional to x minus 1. So y equals constant x minus 1. So you can find your constant, and then if they give you one of the variables, you find one, put it back into the equation and find the second one. If y is inversely, okay, proportional to x, then y is proportional to 1 over x, because that is the inverse proportionality. So 1 is increasing, the other variable is decreasing, or the other variable is decreasing and the other one is increasing. Okay, so now here, if you introduce the constant, then you have y equals k over x. If y is inversely proportional to x squared, so here again the inverse proportionality, then you have y, this is how it is going to, y is proportional to 1 over x squared. So y equals kx squared. Okay, so that will be your equation you are going to use to solve that particular equation. Okay, if y is inversely proportional to 1 over x, okay, then y is inversely proportional to 1 over x. So again, you introduce your constant, and this is what you are going to use. Okay, y is inversely proportional to 2x. So y is proportional to 1 over 2x. Okay, so y equals a constant over 2x. Okay, so as you read the question, either is directly proportional or inversely proportional. You first do the proportionality and then introduce your constant, bring in the equal to sign, and that is what you are going to use to solve that particular equation. So that will be our starter for today. Okay, I thought I'll emphasize what we saw yesterday before I go on to show you other things. Now today I have an example for you. These are past papers. Okay, work out the length using x of x using the diagram. So we have a diagram here. Okay, that is 123 degrees, that is 19 degrees, that is 8 centimeters, and that is x. Okay, now if you look at the diagram correctly, we don't have a right angle, there's no 90 degrees. Okay, so here we can use Pythagoras. Okay, but there is something called the sine rule. Okay, so for instance, if you have a triangle this way, these are A, B, and C. These are the angles at A, B, and C. Now at C, the length opposite is your small c. At A, the length opposite is your small a. Okay. At B, the length opposite, your angle is your small b. So if you want to use the sine rule here, it's A over sine of A. This is trigonometry. Okay, we'll do a video on that, but I will need to explain to you to use it to solve this question, because we can use Pythagoras here. So this A here, the length A, will be the sine of A. A here is the angle at A. B, the length B, is the sine of B. And C, the length C, is the sine of C. Okay, in trigonometry you have sine, cosine, and tangent. So we say sine, cos, and tan. Okay, so now because I don't have any right angle, I can use the sine rule. This is the sine rule, okay, to help me solve this question, because I have the distance and I have the angle. So the angle here, I have the distance, and the angle here, I'm supposed to find x. So I can use the sine rule. So with what I've just shown you and applying the sine rule, okay, applying the sine rule to solve x. So let's look at our diagram again. Okay, so first of all, they want us to find x. So x, which is our length, over sine of 19 degrees, which I have here, should equal to 8 centimeters over the sine of 123. Okay, so this is what we have here. So we've used the sine rule here to create an equation to find x, because we don't have 90 degrees on that diagram, on that triangle, so we can't use Pythagoras. Okay, so here all you need to do is to use your calculator now. So x now will be 8 over sine 123 times the sine of 19. Okay, now x equals 8 sine of 123. All you need to do is to put in 123 and click the sine button. Okay, it's on your calculator. So 8 over 123 over sine 123. Okay, that's what you need to get used to your function. So 8 over, I've put it in 4 figures to be as accurate as possible. In the end, I'll reduce it to 1 decimal place or 2 decimal place. So sine of 123 gives me a lot, and I have reduced it 4. So I have 0.8387, and then sine 19 will be 0.3256. Okay, now so x now, 8 times 0.3256 will give me 2.6048, all divided by 0.8387, which will give me 3.1 centimeters to 1 decimal place, or 3 centimeters to the nearest whole number. Okay, I will write any of them, because if I look at the diagram, I have 8 centimeters. So I'll as well leave my answer to the nearest whole number. Okay, so I can write 3 centimeters or 3.1 centimeters. Okay, so instead of using Pythagoras here, I can't use Pythagoras because none of the angles is 90 degrees. So the next thing I can use is the sine rule, okay, which I've just explained to you. Okay, but I will come and do a video on it because this is under trigonometry. Okay, now this is a calculator paper. They said circle the statement about that are true. So they've given you hints, use your calculator. I wrote it here. But the thing is, there is a way of, if you do add math, the sine of 180 minus x will be sine of x. So if I have the sine of 180 minus 20, that will be 160. Okay, so that will be the sine of 20. Okay, if I have the cosine of 180 minus 20, that will be the cosine of 160. The cosine of 160 will be the same as minus cos 20. Okay, these are higher stuff, so I would rather explain it to you, but I'm just elaborating a bit. Okay, so now if you don't know these things, all you have to do is use your calculator, find the sine of 123 degrees and find the sine of 57 degrees. Both of them will give you the same answer. You circle it. Okay, initially I take it, but I thought I would just go by this because if there's something circle, please circle. Okay, now if you do sine 123 degrees, it will give you different values to cos 57 degrees. So this is not this, it's not, they are not equal. Cos 123 degrees is not the same as cos 57 if you use your calculator right. So this is also not equal. But cos 123 degrees will give you minus cos 57 degrees if you do it on your calculator. So if you use your calculator and you take it each first, the first one is right, the second one is also right, so you just circle it. Is that okay? Now this sign here is in trigonometry is called sine. Cos here in trigonometry is cosine. Tan here in trigonometry is tangent. You can always use your calculator to get the answer, especially if it's in a calculator paper. Okay. So this is another question. This also is an exam question. I just took it straight from the paper, solved it, and I'm showing you. Okay, and it's a higher paper as well. Now if you continue the question, it gives you another triangle and they say work out y. Again, we don't have the right angle sign to tell us it's 90. So we can't use Pythagoras, but we are supposed to find y. We know this angle, so we can use the sine rule we used earlier on. Okay, so y will be the sine of 90, which I have here. And then 8 will be the sine of this angle opposite to, because that angle is opposite to 8. So 8 will be the sine of 57 degrees. So now you set your equation, you can find y. So y equals 8 over 57 times sine of 19. Here again, you use your calculator. So y will be 8 times 0.3256, that is the sine of 19, all over 0.8387, the sine of 57. So y, if you multiply the numerator, will be 2 points. Okay, 2 points. My point is faint here. 2.6048 all over 0.8387. And then if you do that correctly on the calculator, you get 3.1 centimeters to 1 decimal place, or 3 centimeters to the nearest whole number. Okay, here again, I can decide to leave my angle this at 3, because the length here was given to me as 8 centimeters. So whether I leave it at 3.1 centimeters or 3 centimeters is all right. Okay, so this will be the third part of the question. So you can see that these questions are not that complicated. You know them. You've been taught in class if you've been paying attention. So you shouldn't have this, and this is a higher paper. Okay, this is a higher paper. So at times, some of the foundation questions are very tricky than the higher stuff. Okay, so here we go again. Now, to end the lesson, I wanted you to put some of this on your flashcard. So if we have a triangle, okay, we can use Pythagoras to do it. We've done a series of videos on Pythagoras. I'll encourage you. But Pythagoras has to do with right angle triangles. Okay. Now, in any triangle ABC, the area of the triangle is half base times height, the sine of C. Now, if you find the sine of if the angle becomes 90 degrees, the sine of 90 becomes 1. That is why the area of a triangle can be reduced to half the base times the height. Because immediately sine C, the angle C becomes 90, everything here becomes 1. So if you multiply 1 by half the base times height, so that's why the area of a triangle is half base times height. Okay, but at times you don't have it as 90 degrees, so you have to use this formula: a, the base, the height, times the sine of the angle that you've been given. Okay, so I add this to your flashcard. We'll do videos on that to explain. Now the sine rule, which I have just used. So if you have a triangle again, okay, this is the angle at A. So A here is your length. So A over the sine of the angle at A should be equal to B, which is the length, over the sine of the angle at B. And should be equal to C, which is the length, over the sine of the angle at C. So if you know two angles and the length, okay, or two length and an angle, you can use the sine rule to find the other length. All you need is your calculator. Okay, in our time we used to use the 4-figure table. I mentioned it on one of the videos because we're not allowed to use calculators, so we were taught how to use the 4-figure tables. So then most of our calculations were in 4 figures, like this, 4 decimal places, okay, like this one, and then in the final end you put it in 1 decimal place, or the nearest whole number, or how many significant figures you've been asked to do. Okay, now this is the sine rule. Okay, so add it to your flashcard. When we are doing trigonometry, I will explain, but at the moment I need you to know this in case I find a question similar to this before I do that topic. Okay, now 3, we have the sine rule and we have the cosine rule. Okay, so in this diagram, our cosine rule A squared will be equal to B squared plus C squared minus 2BC cos A. So A squared is here, okay, plus B squared, okay, no, a squared is the long part, okay, plus b squared equals b squared plus c squared minus 2bc, which is similar to Pythagoras. But here is the trick bit, okay? A squared equals b squared plus c squared, assuming that you will end Pythagoras rule. But assuming cos A becomes 90 degrees, cos A will be 0. So the whole of this becomes 0. That's why in Pythagoras we can use a squared equals b squared plus c squared. That is if the angle is 90 degrees, because the cos of 90 degrees is 0. So if you multiply 0, this whole part becomes 0. And then you now have the Pythagoras theorem. But assuming none of the angle here is 90 degrees, then you can apply this cosine rule and use whatever angle you've been given. So for instance, instead of 90 degrees, to reduce this part to 0, and you have maybe 65 degrees. So a squared now will be equal to b squared plus c squared minus 2b squared c cos whatever angle. So your angle can either be 65, 35, 20, 18, 14. Okay. So these are trigonometry stuff. Okay. But in effect, everything comes down. If you have cos 90, this goes down to Pythagoras again. Okay. If, as I showed you here, if you have the sine of 90 degrees, this go to have base times height, because 90 degrees is 1, the sine of 90 degrees. Okay. So this is the question I have for you today. Again, this came out of an exam paper. I haven't done anything to do it. Everything I've added is to explain to you how I solved the question. But it's an exam paper and it's a calculator paper. Okay, so that is why I need you, because the function like sine, cosine, tan, and the inverse function, all this I'm going to show you. I think I'll find time when we do trig. I'll show you how to use sine of an angle, cos of an angle, tan of an angle, and the inverse of that. So like the sine inverse of A, the sine inverse of B, the cos inverse of A, and the tan inverse. Okay, I'll use a video to do that. But till we do that, okay, these are some of the things you need to know, because this is enough to help you solve a question like this. Okay, so thank you very much for watching our video today, and I'll see you in the next.